Final round. Here we go. Reminders. This is a velocity versus time graph here, yes?
Yeah.
So these values that you see, anything you think of as an ordered pair, the x value is the time, the y value is the velocity, okay? So, quick review to get us back in the groove here. When was the particle moving at constant speed? That was 0 to 1 because the velocity was a constant 5. When is the particle moving right? That's when your velocity is positive. So that's anything above the x-axis, so 0 to 2. So when is it moving left? That's when it's negative. So velocity graph below the x-axis, so from 2 to 5. The one we are working on, and finally kind of got there right at the end of the period, speeding up. Okay, there was a chart, a previous page about speeding up. In order for a particle to be speeding up, we're looking for velocity and acceleration to have the same sign. Now, that could be both positive or it can be both negative. So when we talk about positive velocity and positive acceleration, positive velocity means it is above the x-axis. Positive acceleration would mean what? What is acceleration on this graph? It's the, what's the word? Slope. Okay, so if we look in the positive section here, do you have a positive slope? You have a slope of 0 and you have a negative slope. So there's no situation where velocity and acceleration are both positive. So now let's talk negative. Negative velocity is everything below the x-axis. So between 2 and 5, is there any negative acceleration?
2 to 3.
And we talked already at the end of class to 2 to 3 because that is your negative slope. Okay? So 2 less than t less than 3. And that's because, what do I want to say? Velocity is negative and acceleration is negative. They're both less than 0. Now, that talk makes 5 easier. 4 was when is the particle speeding up. This is when is it slowing down. What am I looking for now?
One to 2, 3 to 5.
Okay. So officially here we're looking for opposite signs. Okay. So we're looking for opposite signs. So one positive, one negative. And that is opposite signs on velocity and acceleration. It helps that we just did number 4, didn't it? Okay. That helps a little bit. Okay, what'd you guys say?
1 to 2, 3.
Okay, you guys good with that? 1 to 2 is positive velocity, negative acceleration. So that was positive velocity, acceleration is less than 0, and 3 to 5. So 3 less than t less than 5. That is negative velocity, but increasing function, so positive acceleration. What about 0 to 1? Okay, we can't say speeding up or slowing down because it's a constant velocity, no acceleration. So, okay. When is the velocity increasing?
From 2 to 3.
No?
No.
From 3 to 5. No. Never. It's never increasing.
Okay. How do we determine velocity increasing? Velocity increasing is going to be true when what? Velocity doesn't have to be positive, but when is your velocity going to be increasing?
When it's speeding up.
It's not about speeding up or slowing down here.
When both sides are,
I don't know.
Where was that chart that we...
both sides are the same, right?
It doesn't have to do with speeding up or slowing down because this is just velocity increasing which is not the same question as speeding up.
Change your position.
If velocity is increasing, we're looking for what kind of slope here? Positive slope. Because velocity increasing means that your acceleration, you have a positive acceleration. That's what I thought we had a spot, but no, it wasn't on that chart. Oh, there we go. So a positive acceleration is going to cause your velocity to increase there. So 3 to 5. Okay, because it's going to, the positive acceleration is going to push it farther. Positive is going to push it right. So that's going to cause your velocity to increase. Okay. Now, this is where I'm going to have to go back and forth. I made my boxes bigger so I can write in them, but I only have one graph. So we're going to be kind of going back and forth. You can see question 7. When is the velocity decreasing? So what sections am I looking for? Negative slope, because I'm looking for when acceleration is less than 0. And so when is my negative slope?
1 to 3.
1 to 3. Okay. Okay, I split this at a bad spot, I guess, but you have it in your notes in front of you, yes? Are the answers to 6 and 7 the same to your answers to 4 and 5, respectively? And then explain.
Yes.
Yeah. No.
They're not the same because the idea is 4 and 6. At 4, it's speeding up from 2 to 3, but velocity is increasing from 3 to 5. 5, slowing down versus decreasing on 7. Again, not the same. There's some overlap, but not the same. Okay, and the key here, so no, they're not the same, and it has to do with velocity increases where acceleration is positive. It's not that the signs have to be the same or have to be the opposite for that. It's just your velocity is going to increase when you have a positive acceleration. So, no. Velocity increases when acceleration is positive. Okay, ready for 9? How fast is the particle moving at time t equal 4 and in what direction? So, what do we know about time t equal 4? That's what my brain is having to process there. At time t equal 4, what do we know? What's this graph tell us? At time t equal 4, I don't know if I got that set up right. What's the ordered pair here? 4, negative 5. And so what is that just according to this graph? And then we'll go answer the question. That's a time 4, and what is negative 5? That's your velocity, yes? Like just trying to take it to the basics here. Now, their question, how fast is the particle moving? What's fast asking? It's not exactly velocity.
Acceleration.
Not acceleration.
What's the other one?
Speed.
Yeah.
Okay, so we're asking, when they say how fast is the particle going, we're talking about speed. Now, one of the points yesterday was at the bottom of a page because it was off my page and I couldn't circle it. I told you guys to circle it. It's at the bottom of page 143. Speed is what? Absolute value of velocity. So we're looking here of the absolute value of the velocity at time 4, if you will. Because speed is absolute value of velocity. And so then we're doing the absolute value of, well, we decided the velocity at 4 was -5, and the absolute value of -5 is 5. So the particle is moving a speed of 5. We don't have labels, do we? No. Well, I guess up top we do, but I don't have labels in my answer, so don't worry about it. In what direction? Left, because the velocity was negative. Okay, so, or actually, I guess I wrote, yeah, you could write either way. I wrote in negative direction or left, so. You just have to be careful of, you know, is this which way is this particle moving? Horizontal, vertical, that type of thing. But okay. Why do they do this? Number 10. Kind of a pointless question at this point, isn't it?
Yeah.
What is the particle's velocity at time 4?
-5.
V of 4, -5. That's, you know, they should have done that on 10 or on 9 and make speed, how fast is it going on 10. And what does that negative indicate? Negative indicates moving left, yes? So I know I put the same thing, but just a reminder there, as it all gets intertangled and confusing. Okay. What is the average velocity over the time interval 2 to 3? Thoughts on what they mean by average velocity? If we think about
Change
average,
the like y, the y2 minus y1.
kind of, yeah.
It's like changing distance over time.
That's what I was looking for. Change in distance over change in time. I did delta D over delta T. I guess in my notes I have it written out as distance and time, but I think you guys know when you see D and T what we're talking about here. Okay, so we're talking about that average velocity. It's a change in distance over the change in time. Now, the change in time is going to be easy, yes? What's the change in time going to be? Yeah, I'm going to write it as 3 minus 2, but that's the easy part. Now, change in distance. Here's the catch. Do we have position information? It's a velocity graph, yes? So we know the velocity at time 2 and the velocity at time 3. But do we know the position of the particle to figure out change in distance? And we don't have that information. So where did we talk about it yesterday? Okay, bottom of page 145. We talked about velocity versus time graphs. And the question was, that second question, what does the area under the velocity versus time graph tell you about the motion of an object? And it tells you the total distance traveled. Okay, that's the idea of what we're looking at, is we're looking at under the, in that interval, what's the area under the graph? So for a velocity graph, to find the total distance traveled, we're going to do the area under the graph in that interval. Okay? So we're trying to think area. Now, what do we know about 2 to 3? What do you see there? Well, triangle, yes? In other words, I'm trying to find this area here. What do we know about this triangle?
Right.
Right triangle. It has a base of
1.
1, a height of 10. Officially, though, negative 10, yes, because we are below the x-axis. What is the area of a triangle?
X times height divided by 2.
Okay.
Joe,
You just know.
that one, I don't remember.
I would argue you should know that one
Yeah.
as a senior in high school and account student. But I would also argue my Algebra 2
I
student should know
don't
that
know
one.
how
But
to divide decimals. So.
how's that deal with dividing decimals?
I'm doing better at dividing decimals.
Okay. And Augie said base times height divided by 2. I always say 1/2 times base times height.
That's
The same thing. It's just a matter of what your brain, gets. Okay, so if we're doing that, 1/2 times the base of 1 times the height of negative 10. Well, what is 1/2 times 1 times negative 10? Negative 5 divided by the 3 minus 2.
so 8 and 1.
So negative 5. Okay.
You got it right, Aiden.
Yes. I did it.
Okay. And hopefully you're writing some information about how we're getting these answers so that when you have to look back on them later, they'll help. Okay. When does the particle change direction?
3.
No?
What?
1.
Nope.
1 and
Never.
3. 2 to 4.
I give up.
Negative 10.
2 to 4. That
Okay.
you just throwing that number.
Okay, let me ask a question. What's happening when a particle is going to change directions?
A minimum or a max.
And then it stops. And it goes like this.
And what happens when it stops?
Reaches
When it stops, what is 0?
velocity.
Velocity is 0.
Oh.
So we eligible.
When is velocity 0?
2 and 5.
Which the question was changes direction, yes?
At 3.
So changes direction is going to likely be at 2. What's 5? That's the end. So I'm not going to use 5 in my answer. I'm just going to use 2 because, and here's the deal. We go from a positive velocity, which is going to be pushing to the right, to a negative velocity, which is pushing to the left. Fair enough? Okay, so when does a particle change directions? T equal 2. You can think in terms of it's an x-intercept. You can think in terms of when velocity equals 0. Just be careful there because if it's at the beginning or the end of a velocity equaling 0, it's the beginning or the end. Okay, or we could talk about when velocity goes from positive to negative or vice versa, right? I didn't write that in a good spot, but that's when you're going to have a particle change direction. Okay?
Isn't it 2 and 5?
No, it's not going to be 5 because 5, it just stops. The graph never goes, so before 5 the graph is negative. We never have a positive velocity afterwards, so we have to assume it stops. Now, if your graph kept going positive, then yes, I would agree with 5. Okay?
What?
Wrong way. Pre-calc, anybody?
No.
Okay.
Actually, yes.
Yeah. kind of.
I don't know. They're not crazy about the quiz they took yesterday, so. How far does a particle move during the first second, and which way?
No.
5.
The first
That's velocity, sorry.
How far does... Wait, I got this. Feet per second. 5. 5 feet.
That's simple. Is that right?
Mm-hmm. Because, so it's in the first second, yes. In the first second, my velocity is 5. That is 5 units of whatever per time. So 1 second, so here we're moving 5. Okay, that had a constant velocity. So it's 5, feet per second. So technically 5 feet. Now, I don't have labels on any of this, so I just have the 5 there, but it is 5. What did I write? 5 units right in a positive direction. And I know it's positive because it's positive velocity, but
Could you find how far it moves if you didn't have those also?
not necessarily. Okay. How far to the right does the particle go, and when does it arrive there? Sorry, my brain was on the first second there, but okay. So, how far right does the particle go, and when does it arrive there? When are we moving right?
What's positive?
When it's positive. So when he means what's it?
Velocity.
Velocity is positive, right? So when velocity is positive, we're moving right. So we're just talking about what time frame here? 0 to 2, yes? Okay, so when does it arrive there? That's going to be t equals 2. You've got to figure out how far does it go. Well,
7.5 units.
I agree.
But how?
Oh, you take it's going 5 in the first second and then 2.5 in the second.
Like that.
Okay, now.
What?
How did you, I mean, is that how do we do this here?
Just take 5 for the first second,
Uh-huh.
and then the average for the second, and add them together.
Yeah. Basically, you're doing the area of this right here, aren't you? Okay. And so in that first second, what is this? This is a square, not square, looks like a square. It's a rectangle, 5 times 1. In the next second, it's a triangle. 1/2 times the base of 1 times the height of 5. That's the official. I mean, you can kind of just look and know to an extent. Okay, so in the first second, it's 1 times 5. In the second second, it's 1/2 times 1 times 5. So that is going to end up 7.5. And I just have 7.5 units. And it's going to arrive at t equals 2. Yeah. Okay. And we only looked from 1 to 2 because it says how far to the right, or sorry, 0 to 2. So that's the only reason I cared about the right. Okay? 15. What is the total distance traveled by the particle? Total distance traveled by the particle. Well, what do we already know?
We already know this.
You know how far it goes from Wait.
Well, yeah. Use.
Negative 7.5.
7.5.
So what do we already know here?
There's
We already talked about that section being 7.5, yes?
Yeah.
and then that
Yeah.
triangle's negative 5.
Okay, this triangle it was negative because it was underneath.
But if you're just talking
Now, this is total distance. Total distance, your speedometer on your car, whether you're moving forward or backwards, records the miles, yes? It doesn't matter whether you're moving in a positive or negative direction. So total distance, your answer's going to change now, isn't it?
plus 5.
I heard you. I knew exactly what you did there, because I think you were right, except
I
you subtracted. Okay. Now, okay, this little piece was what did we say?
5.
It was 5, which you can think negative 5 because it's underneath, but for our purpose of the question, What is this big triangle? Or do you want to do another smaller triangle? We can do either or.
Take a little bit, 2 times 10 by 2. Shut up. 15.
The whole thing is 15 because it's
Oh, you added plus 5. I was like,
it's
I did not.
1/2 times 3 times -10. So 3 times 10 is 30. Half of that is 15. Or if you're just doing the second half of the triangle, it's 2 times 10 and half of that. So, okay. And again, I'm just putting negatives because officially they're negatives, but that area of that whole section, right? So, total distance. When the velocity was positive, we moved 7.5 to the right. When the velocity was negative, we moved 15 to the left. But total distance means I just want how far did I go right plus how far did I go left. And that puts me at 22.5. Okay? Now, what is the particle's position after 5 seconds?
0.
No. Now it's -7.5.
Yeah.
Okay, so now we're looking at, in the first, when my velocity was positive, we went 7.5 to the right. Then my velocity was negative, so now I pushed back 15 to the left. 7.5 minus 15 is -7.5, which you shouldn't give an answer of -7.5. What's that negative mean?
Left.
Left. So it's 7.5 units to the left. Okay, this is not a good indicator.
12.
We're halfway through the class.
That's time flies so fast.
Okay,
Oh, I forgot there's 28 parts.
we've got more parts, plus we've got 2 more pages of just math to do. Okay, we'll see what we can do. Moving along, moving along. Average velocity of the particle over the 5-second time interval.
We don't have our graph.
I know, now you have to, okay, be smart. You guys can just open your book flat.
Oh.
I have to flip back 2 pages, which is why, okay. Average velocity of the particle over the 5-second time interval.
Wait, can we just like have an idea? What if we took the velocity of each second, added it up, and then divided by 5?
When we did average velocity back on 11, average velocity back on 11, it was what?
Change in distance or change in time.
No.
Let's do that.
We have our change in distance,
We have our change in distance.
which is
-5.
what?
No?
-7.5. Or is it 22.5?
Nope, it's the -7.5. Okay,
Yeah.
because total distance is 22.5.
5.
Change in distance is change of, okay, I start here, okay, I move forward some, I move backward some, I move forward some more, you know, how far, okay, here's where I ended. How far from point A to point B? Not all the extra junk in between. Okay, so our change in distance was the -7.5 divided by 5. Nope, 1.5. Wrong way, wrong way. 1.5.
Okay, I forgive you.
Okay, so that's average velocity.
I don't get it.
Your answer is 15, 16. No.
Oh.
No.
Our answers to 15, 16 the same.
No.
What was 15? Oh,
Total distance. Because that's total distance.
yeah, okay. So the difference was total distance versus, on 16, they said the change position. A good vocabulary word here is displacement. Okay, so total distance, all the stuff, all the times you go forward and backward. Displacement is just how far is my beginning point to my ending point. Okay, so the answer here is no. And I'm going to say total distance versus displacement. Okay. Average speed over the 5-second interval.
What's it?
Oh,
1.5.
4.5.
What?
Actually,
How is he getting this? I'm so
1.5.
confused.
Because this is what he did for the last problem.
yeah.
That's why he's realizing. Okay, so average speed. Okay, so when we talk about average speed, now instead of just looking at displacement, we're looking at total distance.
Oh, so
Because your speed is not just going from the beginning point to the end point, it's all the extra traveling in between if you go forward backwards.
so it's the 22.5.
Right. So this one's going to be the distance divided by the time. It's the total distance, so 22.5 divided by 5, which Aiden did the math for us and says 4.5. Okay.
Yeah.
What is the particle's acceleration over the first second? Someone said it.
Zero.
Acceleration is 0 because the slope is 0. What does this mean? What's this mean about your velocity? Velocity is constant. Okay. Over what time interval does the particle have positive acceleration?
3 to 5. 2 to 3. No, that's. Oh, wait. Is that
It's speeding.
Yes, I'm right.
Positive acceleration, why?
Positive slope.
Positive slope. What is acceleration on a velocity graph? Acceleration is the slope of velocity, the derivative of velocity. So 3 to 5 because we want positive positive slope. Okay, so or it's where your velocity is increasing. Okay. When do we have negative acceleration? 1 to 3, because now we're looking at when the velocity is decreasing. Okay. Okay. When is the acceleration undefined on the interval 0 to 5?
3, because that's a minimum.
Not because it's a minimum, because it's a sharp point. Because acceleration is the derivative of velocity. When is this undefined? We're asking when does the derivative not exist? That's what you're asking. So when does the derivative not exist? Now, I agree with 3. I say there's other answers though too.
1, 0, and 5.
I'm not worried about 0 and 5 because those are my beginning and end.
1.
I agree with 1
2.
and 2. 1, 2, and 3. And they are all basically, they're not smooth curves. Okay? I have written in my notes, we called them sharp corners. I have written in my notes sharp cusp. Good calculus word is cusp. But okay, 24. My brain wants to use a previous answer to help me out on this one. State an interval of time when the particle has positive acceleration but is slowing down.
3 to 5.
Okay, I agree. So and if you're not sure, when were we slowing down? Gosh, that was back on the first page. Slowing down was 1 to 2 and 3 to 5. 1 to 2, 3 to 5. We want positive acceleration, so positive slope, right? So 3 to 5. I wrote down velocity negative and opposite signs. Okay. A couple different ways you can think about it. So, okay. State an interval when the acceleration is negative, but the particle is speeding up.
Oh, shoot.
2
So remember, speeding up, we need same signs, right? So negative slope, but the same signs. And what'd you guys say? Yep. Okay. What is the particle's acceleration over the time interval 3 to 4?
Like positive or negative?
We want a number. So 3 to 4, here to here, acceleration. So what are we asking here?
Slope.
Slope. What is that slope?
5.
Rise 5, run 1?
Yeah.
So it's V prime or it's slope, whichever way you want to think about it, but the acceleration is 5. Okay. Average acceleration over the entire 5-second time interval. So think, velocity, when we did average velocity, it was change in time, distance over change in time. Average acceleration is going to be what?
Change in velocity over time.
Uh-huh. Which means in this case, the velocity at 5 minus the velocity at 0 over 5 minus 0. Well, what's my velocity at 5? 0. Minus the velocity at 0 over 5 minus 0. Yep. Negative 5 over positive 5, so negative 1. And over what time interval is the particle's velocity decreasing at a rate of 5 feet per second every second? Okay. You catch some things they're asking. Decreasing, which means we're looking at negative, yes? 5, and it's feet. Did you catch this? Per second, every second, which is per second. Or feet per second squared is what that is. Feet per second squared is a label of acceleration. Okay, so when they're talking about the particle's velocity decreasing at a rate, we're looking at the derivative of velocity, because rate, that word rate means it's a derivative. So we're looking at the derivative of velocity, which is acceleration. Okay, I guess I need an interval then.
1 to 2.
Because basically, when is our slope? -5, right? The slope is -5 from 1 to 2. Okay? You've got lots of good information here, folks. There's a lot, I know. It's a lot for me too. Okay? But use these questions to go back and hopefully you've made some notes and can figure out what we were doing. Okay, we've got to keep moving. 6, it talks about there's a table below to find all the possibility for an object's motion. Remember, an object's velocity is either positive, which means the article is moving right or up, negative is moving left or down, or 0, which is stopped. Also, then object's acceleration is either positive, negative, or 0, which is back to that constant. So, go through this real quick with you. If your velocity is positive and your acceleration is positive, what is that article or what is that particle doing? And it is speeding up. And it's speeding up here because same signs, right? Okay. What about if my velocity is still positive but acceleration is negative? Slowing down because the signs are opposite. Are you with me? What about if my velocity is positive, but acceleration is 0? Okay, so it's a constant acceleration, and officially the velocity is to the right there. It doesn't really matter much when your acceleration is 0, but velocity is to the right, or a positive direction. Okay. Next row. When the velocity is less than 0, acceleration is greater than 0. Here we are slowing down, opposite signs. Velocity negative, acceleration negative. Speeding up, the same signs. Okay. When velocity is negative, acceleration is 0. Constant acceleration again, and this time the difference is velocity is to the left. Now, bottom row. When the velocity is 0, what do we know?
Not moving.
Stopped. Okay? So on all three of those, I'm going to say stopped. When the acceleration is positive, then we're just talking the acceleration is right or up. When the acceleration is negative, then acceleration is left or down. And when your velocity is negative, there's just no acceleration. My particle is positive or stopped, and there's just no acceleration.
Oh boy.
Okay.
Oh boy. Whoa.
2 pages.
Have your calculators.
Whoa.
At least that's what it says. Okay. Top of the next page, there is a chart. Okay. Just some terminology. This is a good chart to reference. We've talked about a lot of this in those 28 part question. Displacement, your change in position. Beginning point minus end point. Okay. Average velocity. Displacement over elapsed time. Remember, displacement is just change in location. Velocity, it's a derivative of position, slope of the tangent line, speed, absolute value of velocity. We talked about that one. Distance traveled. The sum of the absolute values of the distances between turning points. And that's where I said, you go forward and backwards, you're adding all those increments up, right? And then direction changes. When velocity changes from either positive to negative or negative to positive, velocity does not need to pass through zero or even be defined at a point where it's a sign change in order for direction to change. Okay, so basically that velocity change there. Okay, 7. See what we can do with this. A model rocket is launched vertically upward from the ground level with an initial velocity of 114 feet per second. The position of the rocket is given. Velocity, find velocity and speed at t equals 5. What am I going to have to do to find velocity of anything? Based on the fact I'm given position, velocity is the derivative. So we need to know s prime of t. Derivative of negative 16t squared plus 114t. Okay. Basic derivative rules that hopefully you're memorizing, right? Tate said that pretty easily. Is it getting that one getting pretty easy? Okay. Now, we were asked to find the velocity. So what are we going to do now? And actually, can I just tell you the answer?
Sure.
I mean, it'd be plugging in 5, right? I'm just looking at my clock. You plug in 5, you're going to get negative 46. What kind of label does negative 46 have?
Feet per second.
It is velocity, so it's feet per second. Now, what about speed? Because it asks for velocity and it also asks for speed. Absolute value of velocity at 5, so, yep, absolute value of negative 46, which is 46 feet per second.
Would feet per second be the same as miles per hour?
No. It's the same type label,
Okay.
but they're different units. So it's not going to equivalent the same, if that's what you're asking. Okay. Is the rocket speeding up or slowing down at t equal 5? What do we have to know to figure this out?
Acceleration.
Acceleration. So remember, acceleration is the derivative of velocity or the second derivative of position. So velocity was negative 32t plus 114. Acceleration is negative 32. And what kind of label would acceleration be? Feet per second squared. I think Mr. Kevin likes to use feet per second, or maybe Doc, I don't know, but I just put the square. So, speeding up or slowing down? Speeding up because? Speeding up because velocity at 5 is less than 0 and acceleration at 5 is less than 0. Or in other words, same signs. Okay. What is the maximum height the rocket will rise? Maximum height. What's going to happen there? It's going to be a max. What happens to the height? Or what happens to the velocity? The velocity will be 0 at that instant, yes? So we're looking for when the velocity is 0. Do we have a velocity equation? Negative 32t plus 114 equals 0. You guys can solve that. I'm going to tell you t is 3.5625 seconds according to your calculator. Now, that is the time when the maximum height occurs. How do I find the maximum height?
Multiply that by, I don't know.
Plug that into the the original.
The position.
Yeah.
The max height happens at that time. So the max is at that time right there. So to find the position, you take it and you plug it into your original formula, which is 203.0625. It's a max height, so I'm looking for feet. Okay. What is the speed of the rocket when it hits the ground?
When it hits the ground, it's the ground too.
That's after it hits the ground. But
4.
what is the speed of the rocket when it hits the ground?
100,
What do we need to know here?
14 feet per second.
It is. Why? Wait, do we know that?
Because that's what
That was the initial velocity.
goes up must come down.
That doesn't mean it comes down at the same speed.
Well, that's the
Right.
Now, you've got me questioning because, okay, it's the right answer. So, but I'm like, is that coincidence or is that true reasoning? And I'm not 100% sure. I don't know. It might be.
No,
I don't know.
it's If you,
I don't know. Here's what I need you guys to think. It hits the ground, yes? What is your position when you hit the ground? Your height is 0. So we're looking for when the position is 0, which means we had a position equation. Negative 16t squared plus 114. Don't write what I write. 114t equals 0. In a solving situation like this, you can factor out a t. I think technically I factored out negative 2t. When I factored out negative 2t, I had 8t minus 57. Set each factor equal to 0. So then you're going to get t equals 0 and t equals, I have it written down as 57/8. T equals 0, that's a times 0, right? The height is 0 because that's when it starts. It goes up, it comes down. We're looking here at the 57/8, right? Now we want to know speed. How do you do speed? Absolute value of velocity. So you're doing the absolute value of the velocity at 57/8. So absolute value, where was velocity? Negative 32 times 57/8 plus 114. Do all the math there, and then it does end up to be 114. Okay?
No.
I don't know. I honestly, I don't know. That's why I'm not going to,
Forfeit?
Okay. No.
What?
We can talk about this one tomorrow if we need to. I don't remember off the top of my head. So, yes, do the homework for tomorrow. Power your way through it. Okay? Power your way through the homework. We can go in. Remember, the notes are available, so you can always go in and look at that last page in the notes. And we may or may not talk about it tomorrow. We'll see. Okay?